Hello everyone, I am Mr. Ray. Before I solve this question, let me quickly show you something very important. Let's say we have 2 over 5 plus 2 all over 3. Here we say the LCM is 15. And we say 5 into 15, 3. 3 times 2, 6. Plus 3 into 15, 5. 5 times 2, 10, and we say the answer is 16 all over 15. Okay, let's look at it from this perspective. The LCM as the product of the denominator 5 times 3. When we now say 5 into 5 times 3, here 5 into 15 is same as 15 divided by 5. So we have 3 times 2, 6. So here 5 into 5 times 3 is saying 5 times 3 all over 5. So 5 will cancel 5, 3 will be left. So here we can just say 5 cancel 5. This 3 times 2 is 6 plus. Similarly, 3 into 5 times 3 is same as 5 times 3 divided by 3, and 3 will cancel out. So we can just say 3 cancel 3. 3 cancel 3, 5 is left, 5 times 2, 10. Same answer, 16 all over 15. So that's what we'll be doing here. So here we have the product of the denominator, 1 minus x, 1 plus x. So 1 minus x cancel out 1 minus x. 1 plus x times 1 gives us 1 plus x. Plus, here 1 plus x cancel out 1 plus x. What is left is 1 minus x times 2 is 2 into 1 minus x. And we can simplify the numerator. The numerator is 1 plus x plus 2 times 1 is 2. Here we have minus 2x. All over, at the denominator we have the difference of 2 square. P square minus q square is same as p minus q into p plus q. So 1 minus x, 1 plus x is same as 1 square minus x square, the difference of 2 square. So we have 1 square minus x square, and this gives us 1 plus 2, which is 3. X minus x is minus x all over 1 minus x squared, and that's the final answer. But how can we now split this fraction into this separate fraction? That's where the partial fraction now comes in. Let's go there. So here we have 3 minus x all over 1 minus x squared. But here we have 3 minus x all over. This is same as 1 square minus x squared. So we can apply the difference of 2 square in reversed. This is equal to this. So here we have 1 minus x and 1 plus x. So the next step, we'll now split this into a into 1 minus x plus b into 1 plus x. We'll split this fraction into this and this. Then find the value of a and b. How can we find the value of a and b? We can take the product of the denominator as I've explained later. Here we have 1 plus x. So 1 minus x will cancel 1 minus x. What is left is 1 plus x times a gives us a into 1 plus x. 1 plus x will cancel out 1 plus x. What is left is 1 minus x times b, which is b, into 1 minus x. But what we have at the left hand side is 3 minus x all over 1 square minus x square, or 1 minus x square. The denominators are the same. So it implies that the numerators are equivalent. So we can now say 3 minus x is equivalent to a into 1 plus x plus b into 1 minus x. So if we open this bracket, it's same as a plus ax plus b minus bx. Collecting like terms, we have a plus b is equals to ax. We have a plus b plus ax minus bx. From here, we have it as 3 minus x is equals to a plus b plus, we can now factorize x here, which is x into a minus b. X into a minus b. So comparing the constant here, we can now say a plus b is equals to 3, equation 1. 3 is a constant, a plus b are constant. Here the coefficient of x is minus 1. And here the coefficient of x is a minus b. We can also say a minus b is equals to minus 1, comparing the coefficients of x. So we can solve this simultaneously. Subtracting equation 2 from equation 1, a minus a is 0, a is eliminated. There's a minus here that will make this minus plus. So b minus minus b, minus minus is plus. So here we have 2b is equals to 3 plus 1 minus minus is plus. So 3 plus 1 is 4. So b is equals to 4 all over 2, which is equals to 2. If we substitute 2 for b into equation 1, we'll now have a plus 2 is equals to 3. So a is equals to 3 minus 2, which is equals to 1. So from here, this partial fraction now becomes a, which is 1 over 1 minus x, and b, which is 2 all over 1 plus x, and that gives us the original question. So we've been able to combine this fraction and then split it back into a partial fraction. But there's a quicker way of solving this. Here, if we put x to be 0, if we put x to be 0 here we'll be left with 3, and here we'll be having a plus b is equals to 3, and the equation 1 is out already. We can eliminate b here, this part, by putting x to be 1, because 1 minus 1 is equals to 0. So b will be equal to 0, and we are putting x to be 1, so this becomes 1 plus 1, which is 2a. 3 minus 1 is 2, so we'll be having it as 2 is equals to 2a. A is equals to, dividing both sides by 2, 2 over 2, which is 1. A is equals to 1, straight up, right? Then we can also put x to be minus 1. You put x to be minus 1, a will now be eliminated. So we call it the cover method. It's like you are covering this. When you put x to be 1, you cover this and you solve this part. You put 1 here, so we're having 2a and the rest. Then here, what will now make this to be equal to 0? Like we are saying 1 plus x is equals to 0. It means that x is equals to minus 1. If you put x to be minus 1, this becomes 0. So now we have 1 minus minus 1. So this becomes 2b. Then this becomes is equals to 4. Minus minus 1, 4. And we have 2b is equals to 4. B is equals to 4 over 2, which is 2. So we can just solve it that way quickly, and it is called the cover method.